Welcome to Code Report. I'm your host, Connor Hoekstra. Last week we had 6 contests up until Saturday, starting with 3 contests from Codeforces, round 510 on Monday, Educational 51 on Thursday, and round 511 on Friday. We had from Top Coder SRM 737 on Wednesday. We had the start of the September Circuits contest from Hacker Earth, which will continue to go on over the next week. And from LeetCode, we had the weekly LeetCode contest 103. And I'm recording this video late on Saturday night. Almost Sunday morning, and I'll be posting this early Sunday morning because I have to be out of town tomorrow. So the 2 contests that are taking place today that I won't have the top 10 leaderboards for are Codeforces round 512 and from Code Chef the cook-off, which is at 9 a.m. So make sure to compete in those if you have the time. Taking a look at the top 10 leaderboards, note that we've included round 509 because I wasn't able to include that in the last Sunday episode. We only had one individual that placed on multiple top 10 leaderboards, and that was Scott Wu, who took first in round 509, third in round 510, and second in Division 1 of round 511. But we also had a ton of other familiar names. So in the round 509, in 9th place, we had KRK. In round 510, in 5th, we had Ui, and in 6th, we had I Love Tanya Ramanova. On the Educational 51 contest, in 1st place, we had KMJP, and in Division 1 of round 511, we had a bunch of familiar names. In 1st place, EDS 467, in 4th, Zeman, in 5th, KO Osaga, and in 7th, KSun 48, and rounding out the top 10, in 10th spot was Umnik. Taking a look at the other top 10 leaderboards for the Top Coder SRM 737 contest, we had a ton of big names in the Division 1 top 10 leaderboard. Second place was Tourist, third was Petra, 4 was Qwerty 787788. In 6th, we had XUDYH, and once again, rounding out the top 10 leaderboard in 10th spot was Umnik. And for the LeetCode contest, first place went to John Cram. And looking at the overall top 10 leaderboard for the Codeforces website, we had a few changes. So 3rd and 4th spots were swapped between Umnik and Silo Viale. Umnik is now in 4th. Petra jumped up 1 spot to 5th. KO Osaga jumped up 2 spots from 8th to 6th. LHIC dropped from 5th to 7th. Bank dropped 1 spot from 7th to 8th. Swissstock and Dodoria in 9th and 10th, there was no change. In today's video, we're going to be covering the solution to problem C from the Codeforces Educational 51 contest entitled Vasya and Multisets. The problem states Vasya has a multiset S consisting of n integer numbers. Vasya calls some number x nice if it appears in the multiset exactly once. For example, the multiset containing the values 1, 1, 2, 3, 3, 3, and 4 contains nice numbers 2 and 4. Vasya wants to split multiset S into 2 multisets A and B, one of which may be empty, in such a way that the quantity of nice numbers in multiset A would be the same as the quantity of nice numbers in multiset B. The quantity of numbers to appear exactly once in the multiset A and the quantity of numbers to appear exactly once in the multiset B. And note that the constraints for this problem are that the number of integers we're going to be given is going to be between 2 and 100, and the values of each of those numbers will be between 1 and 100. So pretty straightforward problem. Let's take a look at the examples that Codeforces gave us. So we have 2 examples here. Note that the first number on the first line is n, the number of integers, and then on the next line we have n integers. So for our first example, we have 3, 5, 7, and 1, and we output yes, and then basically the multiset either A or B, which corresponds to the number at that index. So this solution is basically saying put 3 and 7 in the multiset B and 5 and 1 in the multiset A. And obviously that's going to result in a correct solution because there's only one occurrence of each of these values, and we're able to just sort of divide them in 2. So any basically permutation of 2 B's and 2 A's would satisfy for this problem. And for our second example, we have n equal to 3 and then 3 values that are all distinct, and that will lead us to not being able to solve this problem. So we just output no, because no matter how we divide these up, either 3 in one multiset and 0 in the other, or 2 in one, it's not going to result in the number of unique values in each multiset being equal. So in order to sort of understand this problem a little bit better, let's drill down to the second example and sort of modify it a bit to see what happens. So as it is, we're not able to sort of split these values or these numbers into two multisets such that the unique values in each multiset are the same. So what would happen if we added a fourth value that had sort of more than one occurrence? So if we added the number 2, so technically I guess I should have changed n equal to 5 here. This doesn't help us because we have two options here. So say we initially tried to split up 3, 5, and 1 into two multisets where 3 and 5 were in the first multiset A and 1 was in the second multiset B. Our two options are to put both of these 2s into either multiset A or multiset B, or to sort of split them in two and then to have 1, 2 here and 1, 2 here. But this doesn't help because adding both of them to either multiset doesn't sort of change the count of unique values in either multiset. And if we split them, we still don't have the number of unique values equal to each other. Here we have 3 and here we have 2. So no bueno when we have sort of duplicate values with a count of 2. But what if we were to add fifth value that had an occurrence of more than 2 occurrences? So here we've added the value 4, and there are 3 occurrences of 4. So now at this point, there is something we can do. Basically, we can shave off one of these 4s and put it in the multiset that is missing, basically has -1 of the number of unique values in multiset A. And if we do that, we end up with the following. So the nice numbers here are 3, 5, and 2, and we ignore the 4s because there's more than one occurrence for multiset A. And in multiset B now we have 3 as well. So that's basically what's going on here. We're first going to count the number of unique values or distinct values that only have one occurrence in our numbers. And if they have an even number of those values, then we can just sort of split those in half and assign those in either multiset A or multiset B, and we can ignore all the other values that have an occurrence greater than 1. But if we have an odd number of values where the occurrence is 1, we need to see if we have another value that has more than 2, because more than 2 occurrences. Because if it has 2 occurrences, when we split them, it's just going to add 1 to both multiset A and multiset B. But if we have a value that has an occurrence more than 2, so 3 or greater, we can basically shave off one of those numbers, put the individual number in multiset B, and then put the others in multiset A, where they'll sort of be where they will be ignored in terms of counting nice numbers. So that's basically the entire algorithm. This wasn't initially clear looking at the problem. This algorithm didn't immediately come to me. So some of you might be wondering, how do you get to this? So the first step is just to sort of take a piece of paper and work through. It's pretty clear to see that when you have an even number of nice numbers, you just split them in half and then assign them, half of them to multiset A and half of them to multiset B. And then you're left with a case with when they're odd. And if you just work through adding, 2 values, one with the occurrence of 2 and one with an occurrence of 3, you'll see that the 2 occurrences don't help, but 3 or greater do. And that's basically how you can work your way to the solution, is just sort of working on paper and figuring out the cases. So in the case where you have an odd number of nice numbers and you don't have any values that occur more than 2 times, you're just going to output no. So for this one, you would output yes, but without the 4s, you would still output no. And there's one last thing to note is technically for this example, we should show what the output would actually be for the algorithm that I'm about to show via code. And it would look like follows. So note that previously we had the two 2s sort of separated. Whenever we have a value that the occurrence for it is 2, we're just going to always put those in multiset A, and they'll sort of be ignored. And we also had 3 and 5 in this multiset A, but really the way it's going to work is it'll sort of alternate. So first 3 will go into multiset A because it's a nice number, then 5 will go into multiset B, then 1 will go into multiset A. We'll put both of the 2s in multiset A, and then we'll shave off 1, 4, put that in multiset B, and then put the rest in multiset A. So you end up with yes, ABA, these are 2 A's for the 2s, and then the first 4 gets a B, and then the last 2 get A's. So hopefully this will make a little bit more sense when we look at the code. So here is our C++ solution. We have our function Vasya and multiset, which takes a single parameter, a vector of integers, the numbers in our set, and at the top of this function we're declaring a hash map where the key and the value are both integers, and this is basically going to be a frequency map. So we're going to loop through each of the numbers in our vector, and for the key we're going to store the number, and then for the value we're going to post or pre-increment that, and basically at the end of this we're going to have the key as the number and the value as the count of that number. So the number of occurrences that number shows up in our vector. And this will give us the ability to figure out, as we're looping through, which multiset we need to put our number into based on the number of occurrences of that number. And then on the next 2 lines, we have 2 lambdas, 2 generic lambdas. The first one is going to return true if the frequency of a number is equal to 1. And the second lambda is going to return true if the frequency of that number is greater than 2. So EQ1 is equal 1 and GT2 is greater than 2. Then we have 2 algorithms on our next 2 lines. We're going to get the number of numbers that have a frequency of 1. So we're making a call to countif and passing in our equal 1, which is basically going to count the number of sort of values in our frequency map and ultimately in our vector that only have 1 occurrence. Then on our second line, we're going to calculate if there are any numbers that have occurrences more than 2. So this is going to be a Boolean, and we make a call to any of. So basically, as it's saying is, do any of our key value pairs have a frequency greater than 2? And so this will either be true or false. And then we are setting a Boolean odd ones, which basically means do we have an odd number of numbers with an occurrence of 1? So once we have these 3 values, we can basically go about either seeing if it's not possible to solve a solution or to get our correct solution. So we first check, is there an odd number of 1s, and there are no values that have occurrences greater than 2. If that's the case, it's not possible to solve this, so just output no. But if we don't have this condition, then we're going to come in here, we're going to output yes, and then we're going to initialize this Boolean A to true, and basically this is just going to be a flag that for our nice numbers, the ones with only 1 occurrence, it means, do we want to put this in multiset A? And when this is set to false, it means we're going to put that nice number in multiset B. So we're going to loop through each of the values in our vector, and what we're going to do is then operate on the frequency of that value. So the first thing we'll check is the frequency equal to 2? These are the values that we don't care about. And for this, we are going to put them all in B or in A, as these are sort of throwaway values. It doesn't really matter. So I think in the visual solution, I said that these were going into A, but actually they're going into B here. So I apologize about that. The second case that we'll check is the frequency equal to 1? So is it a nice number initially? If that's the case, based on our flag, if it's set to true, put it in multiset A, and if it's set to false, put it in multiset B. And after each of these operations, we need to sort of toggle our flag. So if it's true, set it to false. If it's false, set it to true. And you can just do that with the following here. And then for our last case, this is going to be when the frequency of our number is greater than 2. We first want to check, is did we start with an odd number of nice numbers? If that's the case, we need to shave off one of our current values and put it in multiset B, because if we don't do this, we're going to end up with a mismatch of our nice numbers. And we only need to do this once because there's only ever going to be a difference of 1 between the number of nice numbers in multiset A and multiset B. So once we do this, we can set odd ones to false. And then in every other time we see the same value, we're going to end up putting it in multiset A. And if it was the case that we started off with an even number of nice numbers, then we don't need to worry about sort of shaving off any value and putting in multiset B. They all can just go in multiset A. And so once you do this, you will effectively have output the order in which you put your values either in multiset A or B. Taking a look at our Python solution, once again, we have our function Vasya and multisets that takes in a list in this case called V, and we are setting up our hash map, or dictionary as they call it in Python, and doing the same thing similar to C++, just going through and incrementing the value associated with our number key such that we have sort of a frequency, dictionary, or hash map at the end of this. We don't have nice algorithms in Python, or generic algorithms, I should say. So we just sort of have to hand roll our own to count the number of numbers with only one occurrence and with greater than 2 occurrences. So pretty simple. And then just setting up our Boolean that checks whether we have an odd or an even number of values that occur once. And then it's pretty similar for the rest. So once again, we check if there's an odd number of values that occur once and we don't have any values that occur more than 2 times, we can't solve it. Otherwise, print yes, set up our Boolean to toggle which multiset we're adding our nice numbers to. And here, instead of directly outputting it, we are going to set up a string answer because it's a little bit ugly trying to output without a new line in Python. And so once again, checking here that is the frequency equal to 2, then we just arbitrarily assign our value to multiset A or B. Here we're doing A. Else, if the frequency is 1, based on our flag A, if it's set to true, add it to A. If it's set to false, add it to B, and then toggle the value of our flag. And in the else case, if we have an odd number of nice values for the first time, put it in multiset B, and then toggle off this flag. And for the remaining times that we see the same value, we're going to put it in multiset A. And at the end of this, we just want to print out the string that we've constructed. So the last thing to talk about is the time complexity, which for this problem is going to be linear. Setting up the dictionary is going to be linear. Figuring out the number of values that occur once and that occur more than 2 times is going to be linear. And then looping through each of our values and constructing our string is also going to be linear. So at the end of the day, the complexity of this problem is going to be linear. Taking a look at the contests happening next week, we only have 3 contests, but expect Codeforces to announce 1 or 2 contests at some point. So on Saturday, we have from CodeChef the lunchtime contest at 7. From Topcoder, we have the SRM 738 contest at 9. And of course, from LeetCode, we have the weekly LeetCode contest 104. And once again, throughout the upcoming week, we will have the continuation of the September Circuits contest from Hacker Earth.
As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.